Good morning, good afternoon, class. Have a seat. We are busy with differential calculus. We're drawing cubic functions, not so. So yesterday I gave you 4 sums to do for homework, or 5. You had to, morning, good afternoon. Yes, it's afternoon. Righto, Yichatos. So, listen, I gave you 3 sums, or 5 sums. How many did they give you? 1? Oh, 1 to 11. Okay. So I gave you all the sums. Is it a lot or a little or what? A lot of a little, okay? So this is exercise 11, page 177. 70, okay, and 70. That's it. Right, let's do our thing. Where do we start? Okay, what I'm going to do is I'm going to write down the equation and then I'm going to do it. Okay, I can't have this in the way because it's fairly bulky, as you can see. I'll put it here in the calculator. Right. Any issues with number 1? Any problems with number 1? Okay, out of the 1, 2, 3, 4, 5, 6. Out of the 6 sums. So now, You get the class. Why? No problem, boss.
No problem, boss. Okay.
Inshallah. Okay. Okay, of the 4, 5 I gave you. I'm going to give you 5, 6. I will do 2. Okay, which 2 would you like me to do? Which ones did you have a problem with? You mustn't just give me sums, no? 7 and 11. Okay. 2, I said 2.
Okay, 7 and
11, okay. Right, let's do this. So what is number 7's equation? Let's start with black. Right, number 7. Yes, what's the equation? Y is equal to 4 over 3x cubed. Yes? 2x squared, yes? Yes? Plus 62 over 3. Okay. So when we start, they ask you to sketch this graph. So we start off with the shape of this graph. So this is positive, so the graph goes up then down. Not so. Secondly, x-intercept. What do you do for x-intercept? Let y equal to 0. Not so. So 0 is equal to 4 over 3. X cubed minus 2x squared plus x plus 62 over 3. Not so. So now we check for the factors. We check 1, then minus 1, 2, minus 2, 3, minus 3. Or 6 minus 6. Okay. And which factor actually worked? Sorry? Didn't you guys do the work? So then tell me what is that? Negative 2. How did you get that now? Yeah. Negative 2 is correct. Okay. So you say, so firstly we're going to multiply and get rid of the fraction. So it's going to be 4x cubed minus 4x squared plus 3x, not 4 but 6, no? Plus 3x plus 62. Okay. Now we worked out that f of negative 2, no? So f of negative 2 is 0. Therefore, x plus 2 is a factor. Okay. So that's going to give you x plus 2 into x multiplied by what is 4x cubed? 4x squared. 2 times what is 62? 31. So that gives us 8x squared. What must be added to 8x squared to give us negative 6x squared? What must be added to 8x squared to give you negative 6x squared? And what must be added? Negative 14x squared. So negative 14x squared divided by x is negative 14x. Now that's now a quadratic. So to factorize quadratic formula, one of two ways. Either the factors, in which case it's not going to give us factors here, or the quadratic formula. Not so. So we go x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So if you work this out, it's going to give you 14 plus the square root of 14 squared minus 4ac over 2a. Either, which means to say, this trinomial that does not factorize. No solution on the side here. Which also now means to say that there is no solution that is our only root, it's our only x value intercept. You guys understand? Yes?
So what happens in calculator, not using the correct formula and what formula?
Did you got the silver calculator?
Yes.
Yeah. Now if you look at the silver calculator, the answer here was, I was just punch this in. I put 4 over 3, negative 2, the 1, 62 over 3. I got negative 2 and that base. That's what you're talking about. You see there's an I next to it. That says that the root is imaginary, which means to say non-real to us. Okay? So it's imaginary roots. When you go to university next year, spend a whole week on imaginary roots. Roots that doesn't exist. Spend a whole it's a whole topic on its own. Imaginary roots. Okay. I don't think a week, maybe a day. But in our school setup we'll probably use a week for it. Okay. But it's basically that if you see the I when you use the calculator, you will see that I indicates that under the root is negative. And we look at the root of negative 1, that is I, basically. Okay. So more about that next year? Okay. So remember now we got the x-intercept, which is x equal to negative 2. So let's carry on with our lives. Okay. So now, what's the next thing we need to do? Sorry? You must work out our turning point, not so. Okay, as you can see I don't have space yet, that's why I'm taking it off. You guys don't erase it at this point. We work out now y-intercept. How do you calculate y-intercept? We did x equal to 0. So y works out to be 62 over 3. Thereafter we work out our, what do you do thereafter? Turning point. How do you work out turning point? First derivative, set it equal to 0. So dy dx, apply my derivative, it's going to give you 4x squared minus 4x plus 1. Perfect square trinomial, not so. So you can factorize this into 2x minus 1 squared equals 0, so x is equal to half. Or if you had put that in a quadratic equation, in that formula, that is a quadratic equation. You put it in the quadratic formula, you'll get both the roots to be half. Why? Because under the root will be 0. Okay, that's equal to this thing. Then what do I do with that? I put it into the original. So you'll substitute x is equal to half into the function. So y is equal to 4 over 3 into a half cubed minus 2 times a half squared plus a half plus 62 over 3. So what I do is I put the half in the calculator. Put the half in the calculator. You say 4 over 3 times answer cubed minus 2 times answer squared plus answer plus 62 over 3. Give you 125 over 6. So this coordinate is a half and 125 over 6. Or in decimal that would be 20 comma something, no? It's 20,83. Okay. So what you notice is one turning point. So what does that mean? The turning point and the point of inflection is the same. That is together here at this point. Okay. And this is enough information to draw a graph, not so? Okay, so let's see, you take this off here. Your turning point is defined as that here. Your y-intercept. Okay, just making space here. Alright. So let's draw. So earlier on we worked out our x-intercept, and our x-intercept worked out to be negative 2. Okay, so it's negative 2 approximately there. Then it cuts your y-intercept at 20,6 I think, no? 20,6 recurring. So at the half, okay, now I always tend to write a dotted line for the turning point normally. So that is a half, and on the half it's turning at 125 over 6. Not so? The graph is going up then down. So it's starting from the minimum. The graph is going to go and it's going to turn here. Can you see that, people? And this point here is what? 20,6, which is 62 over 3. And there's the graph. You guys understand? Now questions pertaining this graph. Let's just see what questions follow the next exercise. Let's get a picture. The next exercise also asks you to draw all these graphs. However, in that exercise they have a whole lot of questions regarding the graph. Okay, I'm just looking for my textbook. Why did I do it? Since exams are starting on Monday, so you're not having class tomorrow, no? And during the exam, you can study for your exams. No. Okay, so if you look at exercise 12, just go to exercise 12 then. It says determine and classify the stationary points. That is to us turning points, not so. So that is fine. Yeah? Determine the point of inflection. So here, in this case, the point of inflection and the turning point is the same point. And I can show you. What was the first derivative? The first derivative was 4x squared minus 4x plus 1. And your second derivative is going to be 8x minus 4. Can you see that? If I set that equal to 0, it's going to be 8x equal to 4 divided by 8. It's going to give you Can you see that, people? So that is your second derivative. Okay. Then the next question says, discuss with reason the concavity. Let's look at the concavity of this graph. On the side of the graph, this is concave down. So if they ask you to say where the graph is concave down, it's concave down for x's less than or. Not so. Where's the graph concave up? So this part of the graph here, not so that side. So this is x is more than or. Okay? Next. The next question asks, this is now for the question for exercise 12. Right? They want to know if you can find only one rational root. Check whether the roots are irrational, non-dual. Here you have one rational root, not so, and there's only one root to this cubic function. The others is imaginary, which means to say the cube is not going to cut the x-axis again. Then it says sketch the graph. We just did that with the axis and the coordinates of the stationary points. And the point of inflection, we did that. Sketch the first derivative and second derivative. We're not going to do that. Yesterday we discussed that, no? First derivative and second derivative. Briefly discuss the relationship. We already said what happens with the turning point is actually the x-intercepts of your quadratic function. Alright? Determine the maximum minimum value. Okay, that's given a range there. And then with f of x, the limit as f of x approaches negative infinity and so on. But something else I want to look at, I thought they would have covered it there at least, is this question. Where is f of x times f prime x greater than 0? Okay, where's f of x times f prime x greater than 0? What does greater than 0 mean? Where it's positive. So if you say f of x times f prime of x positive, how do we get a positive when we multiply two numbers together? Positive times a positive or negative times a negative. Not so. So the function must be positive and the gradient must be positive, or the function must be negative and the gradient must be negative. Not so. You all agree that this is your derivative, first derivative is your gradient. Not so, it's your general gradient anywhere along the curve. What can we say about the gradient of this graph from there to there? It's positive. From there to there? What? So this gradient of this graph is always positive. Can you see that? The gradient of the graph is always positive. So, what do we say? If the gradient is positive, we must look where the graph is positive. So that is not going to apply to what we're looking at here. Can you see that, people? So the gradient must be positive and the graph must be positive. So we see the whole gradient on this graph is positive. So here, is the graph wait, I'm going to fall. Okay, here, is the gradient positive or negative? The gradient is positive. And the graph is negative. That's not what I'm looking for. No? Alright. Here, the graph is positive. Positive, positive. So the graph is going to give you positive from 2 onwards. Not so? So in other words, to satisfy that, we say x has to be greater than negative 2. Can you see that, people? But what happens at the half? What is the gradient at the half? Gradient is 0. At the half, the gradient is 0 is your turning point. So since the inequality is asking for greater than 0 only, I will omit what x can't be equal to 1. If this had to be equal, greater and equal to 0, then I would have put an equal sign there, and then I wouldn't even mention this. Okay? But here they just wanted to know where the graph is, and the product of the graph and the gradient is positive. Okay? There's something to think about there, no? You guys are not challenged much enough with your thinking. Right, people, what's the other thing sum we're going to do? Huh? 11. That is the equation to number 11. F of x equals 2x squared. Cubed, yes?
Minus 3x squared.
Yeah?
Plus 8x.
Minus. So where do we start? I thought you were going to give a nice negative graph, man. But okay. Let's just do what we go. Yes. What's the first thing we do? What's the first thing we need to do? The shape of the graph. The graph is going up and down, not so. Secondly, x-intercept. What do you do for x-intercept? Let y equal to 0. So you got 0 is equal to 2x cubed minus 3x squared plus 8x minus 7. So what do we do now? Sorry. Find the factors. So what gave us 0 here? Okay, I will do it, okay? So we will test for which value is going to give us 0. So I go f of 1, it's going to go. So I say, this says say 1 is your answer. Because in case 1 doesn't work, I can just put something else there. Which is negative 3 times 1 cubed squared plus 8 times 1 minus 7. 0. Okay, so I didn't even have to put the answer there. So that means to say therefore, x minus 1 is a factor of f of x, or of the function. Okay? So now to find the other factor, it's going to be x minus 1 into, so x times 2x squared is 2x cubed, negative 1 times negative 7 is positive 6. Sorry, positive 7. Not so. So that would give us negative 2x squared. So what must be added to negative 2x squared to get negative 3x squared? Negative x squared. Not so. So it's negative x squared. Divided by x is negative x. Okay. So this is now a trinomial to us. Can a trinomial factorize? No. We must use the quadratic formula. So x equal to 1, or x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. But what do we notice now? Under the root will also be negative. So what's going to happen here? No solution. Okay. So we got the x-intercept of 1. We have a y-intercept of negative 7. The shape is going up and down. So all this adds to our diagrams. Okay. And again, I'm just taking this away because I need space. Okay. Running out of space here. The next step is the turning point. How do you calculate turning point? First derivative. Not so? first derivative. So f prime x equals 6x squared minus 6x plus 8. So is it equal to 0 then. So you can use the quadratic formula again. You use a calculator, so it's going to be 6, negative 6 and 8. What do you notice? No solution then. Did I write the sum down properly? Huh? Yes. How can it be no solution? So it's 6, negative 6 and 8. You guys also get no solution? Yes, okay. Yes, so let's work out the point of inflection. So for the point of inflection, the second derivative, which is 12x minus 6. That's equal to 0, so x equal to r. So the point of inflection will be f of r. Let's see what we get in here. 0.5. So it's 2 times answer cubed minus 3 times answer squared plus 8 answer minus 7. Whoops. Negative 7 over 2. So the point of inflection is at the half and negative 7 over 2. Okay. So you got the x-intercept of 1. We cut at negative 7. Let's take this out here. At x is a half, so 1 point, x is a half, and the corresponding y value is 3 over 2, which is the half of, and negative 7 over 2, which is the half of negative 7, so it's halfway there. The graph goes up then down, so the graph is going to come from here. That's where the graph is going to look like. Okay, then look something like this. So that point there is half and negative 7 over 2, and this one is negative 7. Is that correct? Just check if the answer is correct. But now, why didn't we get the... Because in the previous graph, like here the point of inflection and the point of inflection and the turning point in this graph was the same. Not so? And this graph looks similar to this graph. Not so? Now, how come I didn't get the turning point here on the graph? You understand what I'm asking? Okay, I'll try and find out, but don't forget, why is this the case? Okay. I can't think of it. And we didn't read any notes with regards to this. If that is the case, what happens and so on. Right? Yes?
How many marks is
Sketching the graph, 7 marks. So know your story. Listen, to work out your turning points already 4 marks. To work out your x-intercept, what I just showed you now with the 3 marks. So that's already 7 marks. They ask you to sketch the graph, another 3 marks. 10 marks. Interpret the graph in terms of If they ask you to work out your point of inflection, another 2 marks. You understand why calculus is so nice? It's a lot of marks for nothing. Like, easy, man. Stuff's easy. But you guys are doing it. You people are the first to do this. Do matric and all of these things. Matric is hard and you won't never understand. We hear that all the time. You won't understand what we're going through. We just slept and we woke up here where we are today. You guys are actually going through it. I feel so sorry for you. But listen, next year come, you're going to tell me, yeah, okay, you won't speak to me next year, but I'm just saying. You will say that to the others now, your other matric learners, if I can do matric again, I'll do it again. Because I will do matric now in 3 months. That's what you'll be talking about next. If you go to university, the amount of work you're going to get, you're going to tell yourself that all this matric work you could have done in 3 months. And I'm serious. So, use this, man, as a stepping stone to embrace the pace of what you need to move at. To make us out. That is why many first-year university students fail. Firstly, they're out in the open. Now nobody's standing behind them. Nobody's telling them what to do and all of those things. And secondly, the pace they can't adjust to the pace immediately. Come do it second year. You're doing your first year again for the second time. Then you'll see now. Okay, I got half of it now. Okay. So embrace the pace. Okay. And do some maths, man, by the sounds of it, I don't know what you people are doing. Right. People, with regards to this question, let's see. Let's see what note they gave us in that. Exercise, this chapter 8. So that, what's the name was, he's bothering me now. Ask what? You know, no? All the things I hear what you people talk. Sometimes I just make like I don't know what you talk about. The stuff you people talk about, yes. This is number 11. Number 11, exercise 11. They ask you what?
They asked about the test that we wrote on Monday.
What about it?
They want the marks.
Didn't you people tell me they want the marks? Okay, well the note that they gave you in the teacher's guide, it says the roots are 1 and 0, which we do have. And then f of 1 is a factor, right? So that becomes our new root, okay. Then the stationary points are none. Okay, because if you work out your first derivative, you set equal to 0, it comes to be a non-real solution. So there are no stationary points. Okay? So stationary points is turning points to us. Okay, now coming back to this one. This one's number 7. So let's see the note made of number 7. Number 7, the roots are negative 2 and 0. F of x, f prime x equal to 0. They say x is a half. So here we have a stationary point at x is equal to half and 125 over 6, which is correct. Then we are told that the point of inflection is also the same. Is a stationary point and a point of inflection. So here they're telling us that this point here is a stationary point and a point of inflection. Okay? However, if you look at this graph, they say this graph does not have a stationary point, but this is the point of inflection. So now what's the difference? What's the difference, people? I don't know. Alright. You got 2 questions for that guy now, no? What is the first question? Well, why don't we put the equal when we have a D? No? And the second one is, you give him a reference to this question. Okay. Why does number 11 as a stationary point does not have a stationary point, however number 7 has a is the known stationary point to us. Okay, which is this one. Alright. I don't pick it up in here, we'll ask somebody else as well. But it wouldn't affect your A or your B for maths, no? You're supposed to get the A. Now don't say I didn't get the A for maths because Mr. Barton didn't know what that stationary point is and why is it not the stationary point, no? So that is not a normal question in the exam either. Okay. Alright, people? That's my story for now. Okay. For homework, you guys can do the remainder of that sketching of those graphs. But I'm not going to give you homework now. So that's that. Alright, we'll stop the video at this point.